We use electronic devices like smartphones, laptops, and gaming consoles every day. But have you ever noticed that they heat up after a while? That's because the circuits inside them aren't as efficient as they could be. When electrons move through a circuit to process and store information, they interact with atoms, losing energy and producing heat in a process called Joule heating. Scientists around the world have been trying to solve this inefficiency of how we store information in electronics. This research field is called Spintronics. Spintronics takes advantage of a property of electrons called spin, rather than just charge, which traditional electronics relies on for processing and storing information. Researchers recently discovered a new mechanism that can generate spin currents by using a new material made of iron rhodium. Even better, the spin currents they generated were 10 times stronger than before.
Typically, quantum magnetization dynamics are only detectable at extremely low temperatures. However, in our study, we leveraged a magnetic phase transition that induces strong quantum fluctuation even at room temperature. This is what enabled us to observe largest quantum spin pumping signals in an accessible temperature range, making a significant advancement in spintronic devices.
This means we're a step closer to low-power, high-performance memory and processors.
Our discovery has direct implications for a device named Magnetic Random Access Memory, in short MRAM, which is non-volatile memory technology based on magnetic materials. MRAM has already been commercialized by major semiconductor companies such as Samsung, TSMC, and GlobalFoundries. It is currently being used or considered for applications in consumer electronics, automotive systems, data centers, and also industrial IoT.
Researchers say they now aim to turn these findings into real-world designs that could change the way electronics work. The hope is that this advance will help make our electronics last longer, and AI computing will require less power in the future.